visible to all of you. Okay. So in this class, we are going to start the Ohm's law. Okay. Okay, everyone. So in this class, we are going to discuss the Ohm's law. So basically, let me tell you what Ohm's law is basically. Okay. So basic, as you know that we have studied about the you can say the potential difference and the current, right? So basically, Ohm's law is the law which gives the idea and gives the relationship between the current and the potential difference, right? So basically, this thing will allow and will basically help us to determine what specific relationship is there between the current and the potential difference. Okay. So this law is very simple, and every keyword which is present in the law, please make sure to write down in the answers whenever you have such kind of questions in the exam, because the invigilator will look out for such keywords. If you do not write that, you will not get the accurate marks. Okay. So basically, the Ohm's law says that the potential difference across the conductor is directly proportional to the current flowing through the conductor at constant temperature. That means that potential difference depends on the current. That if you increase the current, the potential difference will increase, and vice versa. That means the if you increase potential difference, the current flowing through that will increase at constant temperature. Why? Because if you change the temperature, your answer will not be accurate, and there would be some deflection from the you can say the experimental values, right? All of you. Okay. So it's very important to understand the experiment is carried out at the constant temperature. So V is directly proportional to I. That means, as you can see, so V is directly proportional to I. That means if you increase the current, V will increase, or if you increase the voltage, I will increase. And if you remove this proportionality sign, everyone, the what would comes into the scenario is V equals to IR. R is basically what? The constant which comes into the scenario when you remove that proportionality sign. So how do you calculate what is basically specifically your resistance R? The resistance is the ratio of the potential difference to the current of the conductor. Clear? Okay. And R is constant, which is called a resistance of a conductor. And resistance is a property of a conductor which does not allow the electrons or the electric current to flow through it easily. Just like the friction. When we walk, when we basically slide, there is some friction which does not allow the forward motion. So similarly, the resistance of the conductor does not allow the flow of electrons or the electric current. Check all of you. So see the thing, the ratio of potential difference applied across the conductor and the current flowing through it is a constant quantity which is called resistance. So next one comes into the scenario is basically how does the resistance and the current are relatable to each other, right? So as you can see, everyone, if you are having the resistance, as you can see, the current is proportional to V, but current is inversely proportional to R. That means higher the resistance of the conductor, lower will be the current flowing through that. Obviously, bacho, when you walk on a road, you have higher friction. But when you walk on an ice block, it has less friction. So it's very difficult to walk. Similarly, if if the conductor is having very high resistance, the electrons will not will not be able to move or flow through it easily, right? Okay. So if you increase this denominator, the current would decrease ultimately. And if the resistance is small, then the value of the current would be higher as well. Clear all of you? बताओ मुझे कोई doubt आप लोगों को? Aryan, Ritika, Umair, Afreen.
No, sir.
Please note it down, everyone. Ritvika, I've just started the class. Please note down this Ohm's law.
Yes.
Sir, done.
And all of you, please note down this thing as well. And all of you? Atrika, Rayan, Afins, Matt?
Oh,
Yes.
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 Okay, that's great. So if the potential across the conductor is doubled, so the current also get doubled, right? So just, and if the resistance is doubled, the current would become half. Now the next thing comes into the scenario is very, very important, which is the V versus I graph, or basically graphs of Ohm law. So in that, basically, see V versus I graph. So in this V versus I graph, you would have, so basically there are two types of graph. In the exam, either V versus I graph would be given or I versus V. So most of the time, basically, student gets confused between I versus V and V versus I. Both looks same, but there is a difference. If you take V versus I graph, the graph would be a straight line, as we know that, because voltage depends on the current, and right, and the slope would be a straight line. In that case, bacho, as you can see, if you calculate the slope, y-axis upon x-axis, V upon I would become R. Yes or no? Yes or no, everyone?
Yes, sir.
Because we have just talked about V, but in case of I versus V, so when you take the slope, I upon V would become 1 by R. So in that case, the slope that you would get is basically the inverse of resistance, right? Okay? So it's very, very important to understand whether the graph given is V versus I graph or I versus V graph. Otherwise, you would get confused. You will get the wrong answer if you do not look at that graph basically attentively. Okay? Any doubt?
No, sir.
Sure?
Yeah.
Okay. As you can see, steeper the slope, higher the value of R. In this case, steeper the slope, the lower will be the value of R. Right? So basically 1 by R. Lower will be the value of 1 by R. Let me just take it 1 by R. Mistakenly written as 1 over. Okay? So please draw this thing, graphs. Now, all of you, please tell me once you are done.
Sir, done.
Check. Okay, now let's talk about what resistance is basically. So resistance is the property of a conductor which opposes the flow of electron or the flow of current, right? Which is called the resistance. And resistance depends on four things of a conductor: length, area, nature of material, and temperature. So that's why the Ohm's law should be performed in the constant temperature. So it's a very, you can say, very important thing to basically, you can say, to have focus on it so that the temperature does not change very much. Okay, there is not a very, so slight change of temperature could be bearable, but not that much. Okay, and the SI unit of resistance is given in ohms. Okay, so the scientist who was basically who discovered this thing, who basically experimented this thing, so this name was given in that, in the honor of that scientist. And 1 ohm means that such 1 ohm is of the resistance such that when a potential difference of 1 volt is applied to the end and the current of 1 ampere flows through it. So 1 ohm of resistance would be there. Okay. So please note it down, all of you. After that, we'll do the numericals.
Sir, done.
All of you done? Mara told me that he is done. Anyone left? Please let me know.
Done.
Okay. Please do this question. Let me know the answer in the chat. Quick fast, all of you. Only Afrin and Rayan win the answer so far. Mer, let me the answer. Ritvika, please always mention the unit. Okay, right. Okay, Mer. Chicken. Yes, it's 0.050. Very good, all. Please do this question. We got three answer. Umair, Afrin, Ritik answer. Umair, this question is asking the current, not the resistance. Resistance is already given 60 ohm. What did you calculate? Please check your answer. Okay, Ritik. So it will be 0.4 ampere. Please do this question. Let me know once done. All of you, only two answers so far by Rayan and Afri. Okay, one more answer from Ritvika. Okay, Umair, answer please. Umair, your answer was not correct, I think. My answer. My answer. Okay. See, the answer would be 1.7. Here, please have a look at it. Let me just paste some more questions. Give me a minute. Okay, please do question number 21, 23, and 24 and let me know the answer in the chat.
Sir, can you show that one last one? Sir, that last. Okay, sir.
Okay, map. 24th as well, map. Okay, Ritika. Okay. The potential difference across 3 ohm resistance is 6 volt. The current flowing through would be nothing but Vibaya, that is 2 ampere. The car headlight working on is 12 volt and the current was the resistance would be so R equals to Vibaya. So 5 it would be 24. The electrical appliance 25 and electric 230. The current passing through would be 230 divided by 2. So it would be 9 something. 9.2 ohm. Next is when the potential difference of 4 ohm is resistor connected to there, you will pull the charge passing through it. Three. I hope this is clear, all of you.
Yes, sir.
Please do this 25 to 29 and then we'll done with the class. Okay, got the answers. Okay, let's discuss.